Okay, so in this video, I want to highlight something, which is if you are using or doing the things that you are doing because you want to use them as a tools, or you are actually interested in learning this thing. So what I want to say is I just went and I grabbed this book. For some reason, it's Operating Systems, a second edition, um, or I'm not sure, a concept-based approach. Yep, this is what's written here, and the reason is why I'm bringing this massive textbook and this reference in operating systems is just to see how a typical operating system course would look like, and if the things that I'm interested in can be found in a particular reference. Because I really love to read from textbooks that are very giant and considered as a reference for academics. I always consider this as a starting point. But why I'm starting to study operating system in the first place is actually a pretty, I'm not going to say a trivial reason, but the catalyst was, and the first ignition is going back. So I'm someone who's doing machine learning, and thankfully I was able to produce research and to build some awesome projects and to score high in some leaderboards. But what brings me back to study the operating system is I want to understand the environment where my code runs. And it didn't start this way. It started by, if I want to advance my research, I need to automate some flows. So I need to know a bit about Linux and how it's utilized and how can I use it, and to streamline my workflow, okay? Either by writing shell commands and maybe doing bash scripting, whatever Linux can provide to streamline the environment and the workflow, okay? So this is how it started, and then I found like this is very crucial. It helps me to streamline my work, okay? Because whenever I'm doing something, I found that I want to do X, and X is available using Linux. And it makes sense. We have every single server is built on Linux. The shell is just a Linux. So this is a reality that you can't escape. Now, going back to the point that I want to make. So I'm reading Operating Systems, this giant textbook, one more time, and going through a material on the internet for Linux. Not because that I want Linux or that I love Linux. Of course, knowing something new is it's somehow exciting, right? But this is not the point. The point is that I want to use it. I have a purpose for that, that I want to use it to streamline my workflow. So let's say there is some massive on 2006 Reddit, they say that, or like any kind of website that someone suggests to you to build a kernel from scratch. I wouldn't go and do that. I would just stick to the things that I'm interested in learning, and since like it maximizes my productivity on one aspect of my work, okay. Now there is one thing. So now doing and understanding the operating system is because I'm not really going to actually put myself in a position where I want to work as a Linux administrator. No, this is not my thing. It's because I want to take some small piece of that. So I'm using it as a tool more than I want to learn it for the sake of learning it, or for the sake of having the skill. So yes, of mastering this particular field. Now, this is pretty interesting because the way that computer science is shaped and the tools around us, there is some sort of abstraction. I remember when Lex Fredman asked some of his guests about, do you think that if you were to know the logic and the transistors, the hardware in short, that runs your computer, would that make you a better, or will make your PowerPoint presentations better? In any way, no. These are like way too many abstraction levels, right? So, and he responded by, I think he put it nicely in saying that the engineers who designed this were actually mindful that if someone is working on this abstraction layer, they don't need to get distracted by that distraction layer. Abstraction layer. I kind of mixed up the word. So this is how it is now. But for some reasons, it gets very blurry. You don't say like, this is the operating system layer. I don't need to get myself into that. Yes, for most of the time you don't, but if you think you're starting to get too closer to that, you will need to understand it. Because at first you might run your notebooks and you don't need to do anything about it if your notebooks are running on Google Colab or Kaggle notebooks. You have your Docker containers up and running, but if you are the one who sets the Docker containers, you at least need to have an understanding of how the operating system works. So at that time, the line drawing the abstraction layers will get a bit blurry, right? So this is something that you need to pay attention to. Now, going back to our first arguments, that you want to identify whether you are learning the things for the sake of learning it or for the sake of using it as a tool. Now, let's go to the computer science as a field. What's interesting about computer science is that it's not a science, okay, and it has very little to do with computers. And in fact, you would notice this by yourself if you have went to any computer science, let's say university, you have did computer science before, you will see that they don't teach you anything about computers. All what you do is learn about procedures, abstractions, you learn about programming, you learn about how to think about the algorithms, the data structures. So I remember it was nicely put on SCIP, Structure and Interpretation of Computer Programs. It's one of the most amazing textbooks that have influenced the way I thought about computer science. They said that computer science has little to do with computers, just the same as computer science has, just the same way as geometry has little to do with geometrical or to do with geometrical instruments, right? So these are like completely two different things. There is computer science and there are computers, and computer science is not making you better at understanding how the computers work. It might, but it's not about computers directly.